Good morning, everybody, and welcome to Ellensburg, Washington, USA. Thank you for joining us today. We have blue sky. There's a nice wide shot of campus. We got a couple inches of snow late yesterday afternoon on Christmas Day, but that snow will not be lasting much longer. It is rapidly melting. We're approaching 40 degrees Fahrenheit here on campus. The campus of Central Washington University. The local time is 11:47 a.m. Pacific time, and today's date is Thursday, December 26th, 2024. Looks like we're loud and clear, and it's so nice to have more than 200 of you here live, standing by. You remembered what day it is. For many of us, we're on vacation for Christmas time, and you forget what day of the week it is. But you remembered. Thank you for being here. And those that are watching in replay, yes, of course, in 15 minutes or so, the program will begin for real. But since I'm live with a bunch of folks, approaching 250, people are pouring in. Let me say hi to a number of you. Where are you viewing from on this Boxing Day? Thank you, Wendy. I don't really even know what Boxing Day is, but many of you are saying that, so thank you. I'm expressing my ignorance right now. I've heard of Boxing Day. I don't know anything more than that. Google Earth by Glenn is in Liberty Lake, Washington. Hello, Glenn. Brandon, hello. Letha Lee. Ed is in Johnson Creek, Washington. No, Johnson Creek, Wisconsin? Oh, Ed, you're originally from Johnson Creek. Yeah, you're just from Crick, as we used to call it in Fort Atkinson. But you're up there at River Falls, Wisconsin today. Go Badgers. Cincinnati, Ohio. Edgewater, Florida. Trent is in, hello from the Josephine Ophiolite in Southern Oregon. Northwest Lifer, that's Kay from Birch Bay, Washington. Garth is from Placitas, New Mexico. Arhan is from the Amsterdam in the Netherlands. It's not the Amsterdam. You're from Amsterdam, Arhan, in the Netherlands. Don is in downtown Los Angeles or thereabouts. Paul is currently in Seattle. Okay, Paul. Joe is in La Grande, Oregon. Robert is in Zermatt, Switzerland. You may be vacationing, but what up, homie? Anyway, nice job, Robert. I'm sure it's beautiful there. It's beautiful here, too. I'm really going to enjoy the sun this afternoon, walking around before I head home. Torrance, California, that's Frank. Miko says, hi from Australia. Hello, Miko. Hello from the Northern Hemisphere. What's the temperature down there? Are you cooking today? Troy's in Dubuque, Iowa. Greater Good says it's Sasquatch season. All right. Huntington Beach, California. Come on. Don's in Fairbanks, where it's +4 Fahrenheit. What, you haven't had bitter cold yet, have you, Don? Yeah, Don. It's not normally above 0 this time of year, is it, Don? William Dunlap is in Elmer City, Washington. Hi, William. Garrett, the Dutch night owl from the Netherlands. Happy birthday, Garrett. Gary is in Kalamazoo, Michigan. Gary Paul, backcountry Gary Paul, is in rainy Darrington. So, Gary, I hope that you enjoyed your time with Dawn and maybe Jesse on the island of Kauai, and you're back in the saddle here with us. Thank you, Gary, for everything. Tonight, there is an episode of The Index Granite premiering on PBS in Seattle, and I noticed it just got posted on YouTube, so you can type into YouTube right now if you want. You got 7 minutes. You can watch the Nick on the Rocks Index Granite show for free on YouTube, and we'll see you in 7 minutes. Paul is in Glasgow, Scotland. Hello, Paul. Dave is in Dublin, Ireland. Hello, Dave. Janet says it's 5 degrees centigrade in Penticton, British Columbia. Hello, Janet. I like your Canadian flag there. Lorraine is in Vermont. Hello, Lorraine. Richard is in Surf City. Regine Bellefontaine says hello from Cardamage, France. Hello. Hello, Regine. Mr. Tony, 19. Sup, my fellow Oregonians. Naoki Aoshi from Yokohama, Japan. Good morning, good afternoon, good evening. Another Don. It's coming this weekend. Oh, Don, you're talking about the frigid air. Got it. Yeah, we've been very lucky with we usually have a bitter snap or two, but we haven't had one of those yet. Vicky's in Dallas, Texas. I'm down to live, I think. Susie says, good morning from Jeff and Susie in Hemet, California. Hemet. Hemet? Hello, you guys. William is in Bishop, California. Hey, I'll meet you at Rusty's Tavern tonight. How about that? Boy, there were some wild times at Rusty's Tavern on the last night, each time that I taught Bishop our Geology 210 class down there in the Owens Valley. We stayed at the White Mountain Research Station on East Line Street. Kevin's in Hermiston, Oregon. Laila. Oh, cripes. Salmon Creek, Washington. Come on, I can do this. Lila. Maybe it's just Lila. Good morning. Lindsay Malone. Lindsay, I just got your email. Thank you. If I can remember, I will go to a couple of those photos before we quit here today. Thank you for the last minute help. Jerome Lessman, Nanaimo, British Columbia. Merry Christmas, everyone. Hello, Jerome. Saber. Jeff Tepper and I. Oh, okay. Carol says Carol Sardar is married to Jeff Tepper, and Jeff and Carol are in Tacoma. Buongiorno. Italiano. Yeah. What? Jocelyn is in Quebec, Canada. Hello. And so on. Great. Okay, I'm in a good mood. I love the blue sky. We have all of our kids coming home, so we had a quiet Christmas day, Liz and I, and our middle son Sam, who's still with us at home. And the baby boy and his serious girlfriend are arriving this afternoon. They were at her family's place in Portland, Oregon, the last week, I think. And the oldest boy and his wife and our 4-month-old grandson will be arriving tomorrow. So Liz has been patiently waiting to see her grandson after 2 months of not seeing him. So she's like, FaceTime and all that is fine, but it's not the same as holding him. So she's very much looking forward to getting everybody together tomorrow night. So we will have our Christmas Eve and Christmas Day this weekend. Okay, let's give you another shot out the window in case the sun goes away. No, it's still there, man. Come on, it's still there. Let me play with the camera. I'm having such a... Let's... Our valley gets so fogged in, the inversion sets up and we don't have blue sky in the Kittitas Valley for days and days, sometimes weeks. And we've had pretty good luck this winter so far. But it's been foggy and gray and misty and raining and freezing fog and all that stuff. So to have this blue sky is delightful. So I'm just showing it off here before it goes away. Yeah. All right. I got to take a walk. I'll give you another shot out the window. Hang on. Let me get that set up. I'm not going to do a herky-jerky dance today, I don't think. I don't want to pull something. So thank you so much for joining us today. Our program will begin in 5 minutes. Hope you enjoy this episode called Teanaway Bimodal. I think it will be a good one. Now I just jinxed it, but I think it'll be a good one. That's part of the reason I'm excited. I'm happy with what I put together, but we'll see if you like it. Okay, see you in 5 minutes. Hot mic. Okay, don't get too cocky now. You like what you have, but you're going to screw it up if you're too slow. You have to keep the pace going. There's a lot. You have no idea how long it's going to take you to go through. But remember, you got video clips, and each of those video clips lasts a minute or two. So you can't get bogged down. Just keep it going. Remember, your plan this morning was to do 2 passes, right? You go through your papers quickly, boy, and then you get to the slides. You got 2 cracks at it. You can go fast with the papers. They don't have to, every last person doesn't have to understand everything with the papers. Keep it fast. Keep it brisk. And this is a transition show, as you need to remind everybody. This is a transition show. Right. Okay. All right. Just focus on getting started. Keep it frickin' brisk, okay? Go take your walk now. Come on. You can do this. A pleasant good afternoon to you all, and welcome to Ellensburg, Washington, USA. Today's episode is entitled Teanaway Bimodal, which means we're looking at 2 different kinds of lava flows, both basalt lavas and rhyolite lavas, brown and pink. Brown basalt, pink rhyolite. And they're on display just north of town. So, of course, as soon as we start, we've got this guy doing his thing outside. He's working hard to get all the snow and ice off the sidewalk. It's a bit distracting at the moment. Whatever. I got to power through. So, In addition to bimodal volcanism today, it's a case study. I'd like to look at one formation, one geologic formation for the entire hour plus, the Teanaway Formation. It's just north of town. It's a place that's beautiful. It's the Teanaway River Valley. And I ultimately want to give, still distracted, here. The main thing I want to do today is show you how exciting things are currently. So you already know Jeff Tepper, he's in the live chat. You already know Michael Eddy. He did a Zoom chat with me a few days ago that maybe you saw, and if you didn't, I'll give you a couple of clips today. These guys and others have helped us see a brand new plate tectonic picture, a brand new plate tectonic story for the Teanaway lavas and other bimodal units known as the break-off belt magmas. And by going back in time and literally going back to Israel Russell and George Otis Smith and Daniel Clayton and David Lofgren in the 1970s, I'm hoping you let you see by doing a little historical account. This is like a throwback to last winter when we're going way, way back and reading some old papers. Brett's will even show up today a little bit, just very, very briefly. But the idea is that if we realize that there are three main pulses of attention, geologic attention by field workers in the 1890s, in the 1970s, and recently, we can see that each of those times propelled us and gave us a giant leap forward in understanding details and interpretations of the Teanaway Formation. But my ultimate goal is to say we are in one of those exciting times. And yeah, I'm friends with those guys, but like even if I didn't know Tepper and Eddy, I think I still would be giving you the message that this is an exciting time, and I ultimately want to show you why it's exciting instead of just saying it's exciting over and over again. I want to show you. So to give you that historical context is important. Okay, so you've got two passes at this, and I want to keep this fast because I've got a lot of visuals for you. This is a visual day, and I'm excited to share the video clips and the photos that I have for you. But there's two passes at this. The first pass, we'll go through my papers very quickly, and we'll even read a little bit from the old papers. The second pass is all the visuals that I have ready for you in the slideshow. Okay, ready? Begin. I think if I go to CircleCam first, let's make sure you know the resources that are available to you. If we click on Cascades in the upper right-hand corner, this is nickzentner.com, right? We've got Jeff Tepper with a short essay written specifically for us. Going back in time, we have Mike Eddy's 2017 paper, Roland Tabor's 1984 paper, Paul Clayton's master's thesis, University of Washington, George Otis Smith, 1904, a stunningly beautiful Mount Stewart folio, and Israel Russell, a name that we kept talking about last winter, doing the first detailed work on the Teanaway. Before we leave nickzentner.com, let me make sure that you know that I keep adding to these places where we have video library, for instance. So I just added this one yesterday. Each of these conversations have happened recently. Like I've had 3 recorded interviews with Jeff Tepper alone. And so the Eddy conversation and the Tepper conversations factor into today, and then some of this is for like February. Finally, I just feel like I want to let you know that if you have not been keeping up with PBS television or you don't subscribe, you can watch these Nick on the Rocks episodes for free on YouTube. And one way to go to them is right here on my YouTube, on my website. This one just came out like an hour ago. But each of these are 7 minutes long. And Gary Paul, who's in the live chat right now, was a major player in putting those episodes together. Okay. Pass number 1, here we go. Go to Docky and let's run for daylight. Yeah. I'll see you again Saturday morning, Pacific time. We know that. Here we are the day after Christmas, and I'll see you again Saturday morning, 8 a.m. Pacific time. We are in blue. What's blue? Blue is the 40s. There's a lot going on in the blue air time, and really we're transitioning from late 50s into 40s, but I am in no rush. I am in no rush to leave blue. In fact, we might be even blue in L and M. And you're like, I don't get it. Why aren't you talking about the Cascade Volcanic Arc? This is Cascades A to Z, is it not? Why are you burning through half of the alphabet before we even subduct an ocean plate to make a volcanic arc? This is crazy. I got two answers for you. One, the basement was important for the Goat Rodge project. Okay, fine. The second one is that this Tepper trilogy and these blue stories are fascinating, fresh, and brand new. I mean, he's on the list, man. Jeff Tepper. So we're going to use all this the best we can. And I don't want to get bogged down, but I feel like I want to express just a slight fear. Are you willing? Can I be transparent? Secret? There's a chance that once we start the Cascade Volcanic Arc, it's going to get boring. Like, we're done with exciting plate tectonic reconfigurations and spreading ridges and rollbacks and split-offs and break-offs and everything else. It's just like, like, we're going to find some stories, probably, but I'm really into all this changing plate tectonic stuff happening during the Eocene. So part of me doesn't want to go on to green. Okay, I've said it out in the open. I'm sure we'll find some good stuff, but part of me is thinking that, like, are we really going to find as cool a stuff in the 30s, 20s, and teens? Probably, but I'm not sure until we get there. Okay, right. So now I feel better. Thank you. Docky, here we go. Okay, so yeah, we're going to be in blue for quite a while longer because this is boring as hell. Just kidding. All right, we know that this is about to start, okay? I hereby declare that the birth of the Cascade Volcanic Arc will start the first Saturday in January. So if you're getting impatient, give me 2 more letters after today, pre-Cascade Volcanic Arc. Would you please? Give me 2 more. And then, sure, we will start the Cascade Volcanic Arc on the 4th of January. All right, so this is going to start on the 4th of January. You heard it here first. A reminder that this is bimodal. A reminder that if we have basalts and they're dark, they're over here on the left. If we have pinks and beautiful rhyolites with quartzes within them, that's over on the right. This is what bimodal volcanism is. The Teanaway Formation is bimodal in a beautiful way. Breaking news, all of these break-off belt magmas are bimodal. The basalt of Summit Creek has rhyolite also. The basalt of Frost Mountain also has rhyolite. This is new to me. The Natchez Formation has basalt and rhyolite. Every one of those break-off belts, at least in central Washington, they have the same signature and they have the same rough time frame. That's exciting to me. So Haley Finch, you were collecting the sandstones of Summit Creek and the basalt of Summit Creek right along U.S. Highway 12? I think it's the same stuff as the Teanaway and the rest of these guys, roughly. Okay. Keep it going. Keep it going. Yeah, it's a mess, but we have been pulling out stories with these lavas before the birth of the Cascades, but after the accretion of Siletzia. These are loosely known as the break-off belt magmas, termed that way by Jeff Tepper. Now, into last episode, we had green for the suture between Siletzia's accretion and red for the break-off belt magmas, which are inland just a little bit. Suture of Siletzia, 51 million years ago, break-off belt magmas coming up. They're bimodal, and they're inland of the suture because really, as Jeff was telling us last time, the location of the break-off belt is the location of where Siletzia's edge is in the subsurface. Keep it going. Even this guy. Yeah, we've got break-off belt magmas down to the basalt of Summit Creek. It's not just basalt. There's also rhyolite of Summit Creek. And today, we're spending all of our time at the Teanaway Formation. More localized map, Ellensburg, Wenatchee, Seattle, Olympia, Interstate 90, which is the boundary between the North Cascades and the South Cascades. We haven't talked about that in a while. But here is the Teanaway Formation with just one number stamped on it. Where does that number come from? Are there other numbers that we can use as well? Yes, we are transitioning today. So, would you mind, please? The last couple of episodes, we were out in the Pacific Ocean, building Silesia, accreting Silesia. We were regional. And today, we are narrowing our focus to the Teanaway Formation only. Saturday and next Thursday, we will be back out to the Pacific, going all the way to the east into Idaho. Some of you know where we're going. It's the rollback story, also Jeff Tepper's work. But I want to put today in context with a few letters prior and a few letters coming in the future. So we will be over here looking for a continuation of this breakoff story somehow with geology that Tepper has been learning with his students in the last 15 years. Finally, even in the subsurface, it's not quite as vertical as this, but yes, we've got the suture and we've got the breakoff. Okay, I'm still in the first pass, and now I want to go back to the earliest days of geologists looking at the Teanaway Formation. Pat from Natchez, I don't know if you're with us, Pat the pilot from Natchez, sent me a gift, and it is this beautifully bound old paper, a preliminary paper, The Geology of the Cascade Mountains in Northern Washington by Israel Russell. And Israel Russell in the 1890s was getting off the train at Cle Elum, Washington, and walking and being on horseback and doing the first proper geology in Central Washington, looking at the Teanaway Formation. You know why we're doing this, right? We're doing this not just to kill time. We're doing this to set up why it's such an exciting time right now with Tepper and Eddie. So I've got just a few pages. I want to try to do this quickly. Yeah, there's some beautiful photos. I'll give you better looks at them in a second with the slides. But here is the Swak sandstone, and here are these enormous and very beautiful and striking looking Teanaway feeder dikes. These are basaltic feeder dikes. Much more coming on those in a second. But a full page with some photographs in the 1890s. Let me read a little bit. I'll just look into your eyes as I read. Israel Russell, 1890s. He's talking about the Cascade Peneplain, Gary. One of the most striking features in the present river drainage of the Cascades is the low grade of all of the larger streams far toward their ultimate sources. In several instances, a low grade, that is, a slope of perhaps 10 feet to the mile, is found from the mouths of the rivers to within 5 miles, and in some cases a considerably less distance, of the main divide. Throughout these low-grade tracts of streams are mostly free from cascades and flow over gravel deposits which deeply fill the true rock-cut valleys. Since the period of deepest cutting of the valleys have been filled with gravel to a depth of some instances of 600 feet or more, and then in part or wholly re-excavated. Okay, am I on a tangent? I don't think I am. You remember one of our lingering questions, I think through the entire alphabet, is when are we having uplift and why? And these original observations by Israel Russell, on foot and on horseback, looking at the drainages, the rivers flowing away from the crest of the Cascades, mostly in the north, I'll admit, but looking at the amount of incision and the depth of those valleys, and then their relatively low gradient, once they get down to that shockingly low level, they struck Israel's eye. And that ultimately is an uplift story, which we will continue to try to revisit. Not today, I don't think, But this uplift thing is going to continue, and maybe I'll start hearing from uplift experts, or maybe I'll find some as well. Okay, don't get bogged down. There was another page. Oh yeah, beautiful Ingalls Lake, 1895 or whatever. Okay, thank you. I'm going to keep using, where's that other, here. Israel Russell mistakenly called the Teanaway basalt one of the Columbia River basalt lavas. In other words, he saw these flood basalts in the Teanaway. We now know that they're way too old for the 16-million-year-old German chocolate cake. But Israel was in here for the first time, and he saw a bunch of flood basalts, and he even saw feeder dikes, fissures in other words. And so he called the Teanaway the lowest sheet of the Columbia lava. They consist of lava flows, of which there are several, and associated volcanic tuffs. He's talking about the Teanaway basalt. In intimate association with these, in the region embraced between north and middle forks of the Teanaway River, there are peaks composed of nearly white rhyolite. This is a theme of today. It's not just basalt. There's nearly white rhyolite, says Israel Russell, doing fieldwork in 1898. The relation of the rhyolite of the Columbia basalt, the relation of the rhyolite to the Columbia basalt is not well known, but it seems to be a dike exposed by erosion and much shattered and altered in color by weathering. Put that in the back of your mind. Let's move on. We leap to the 1980s, which didn't make the chalkboard, but the 1980s is a paper by Roland Tabor, which Mike Eddy, in a recent conversation on Zoom, he said this is the most amazing paper, and this paper alone got Mike Eddy deeply into Central Washington geology. Ages and stratigraphy of lower and middle tertiary sedimentary and volcanic rocks of the Central Cascades, application to the tectonic history of the Straight Creek Fault. Tabor and others, USGS. I want to read a couple paragraphs here. I'll not look at you this time. I'll actually let you read along with me. Basalt and andesite flows, characteristically glassy to very fine-grained black rocks, with or without small phenocrysts of plagioclase, and locally olivine characteristic are also numerous chalcedonic amygdules. Typical basalt. He's saying andesite. I don't know if there's that much andesite in the Teanaway, but whatever. Well-developed columnar joints are common. Flows of the basalt are as thick as 20 meters. We estimate the thickness of the Teanaway basalt ranges from less than 10 meters near Table Mountain on the east to at least 2,500 meters near Lake Cachis. And you're like, I'm watching in France. I don't know where this is. Will you help me see where this is? Can you show me a couple maps? All those visuals are coming, I promise. I'm just trying to get you interested and give you some detail that maybe will not come with the visuals. I'm officially jazzed today. Settle down. No fossils that can be found in the Teanaway. This is what I want to read to you. Rhyolitic tuffs and flows overlie the Teanaway and are interbedded in the lowermost part of the Roslyn Formation, which sits above the Teanaway. There has been confusion about the stratigraphic position of some of these rocks, and earlier workers indicated that the rhyolite is post-Roslyn, or possibly both pre-Roslyn and post-Roslyn. I'll give you context in a second. Fission track ages of about 55 and 21 million years old are a puzzle. And we conclude that the older sample, this is rhyolite he's talking about, dated, was contaminated by pre-tertiary detrital zircons, and that the younger sample was from a dike. As the rhyolite is interbedded in the Roslyn, which is conformable on the Teanaway, the rhyolite is the latest expression of Teanaway volcanism. Small amounts of rhyolite crop out throughout the Teanaway section, although many of these outcrops are probably dikes. Okay, are you ahead of me? Are you an excellent student here? If you're an excellent student, you've watched the Mike Eddy conversation. And not only was Mike Eddy talking about the importance of that paper, Mike Eddy says, I got some skills, and I've got a lab. and I can get incredibly precise dates. I can solve some of these problems this guy Roland's talking about. I'm going to solve some of the problems that some of the others folks are talking about as well. That's why this is such a heady time. Detailed geochem from Tepper, detailed age precision from Eddy, and suddenly we have a whole new tectonic story. Okay, let's transition to Mike, and then we start going to the slides. So this is Mike's famous diagram, and in the conversation we're about to hear from him, he really likes this one as well. I'll let him speak for himself. But here's a major unconformity between the Swauk Formation below, the Teanaway Formation above. So there's angular folded Teanaway here. Things are not as folded in the Roslyn sitting above and the Teanaway itself. The precision is laughable. And here's Mike saying, my date at the base of the Teanaway Formation is 49.341 million years ago, plus or minus 0.3033 million. And he's like, before that, we had plus or minus 0.6 million with the potassium-argon date. And some of these Silver Pass volcanics, a little bit older, I can get down to easily way less than 100,000 years. And these poor folks doing zircon stuff just a few decades ago had plus or minus like 5 million years. So he's not showing off necessarily, but Mike Eddy is showing off, saying, look, I can nail these dates for you guys. And there are major pluses that come from this. There's 400 separate basaltic feeder dikes in the Teanaway, feeding the Teanaway basalts. But not one of those dikes shows up in the chump stick. This is a staggering date, which I think I have a sketch to show you. But the entire Teanaway lava activity, whether it's basalt or rhyolite, is all happening in less than 200,000 years. And you're like, that sounds like a lot. No, it doesn't. Not for the stories we're telling. That's a crazy short duration for lava activity, volcanic eruption activity. So yes, not only the Teanaway, but all of these units in Jeff Tepper's break-off belt magmas are bimodal, and they all sit on top of this unconformity, except for the Natchez. Mike talked about being frustrated by that. This, setting up some conversations with Mike. Here's the folded Swauk. Here's the basaltic feeder dikes that are not folded in the least. Flooding basalt on top of the Swauk swamp. Here's Mike's date at the base. Here's Mike's date at the top of the Teanaway, which he says is not as satisfying, but he used some detrital zircons and some of this Roslyn sand. But he's got all this Teanaway action, basalt and rhyolite, wreaking havoc in the middle of this sedimentary basin for less than 200,000 years. Why? Why is it such a short-lived event? This goes back to Jeff Tepper's discussion the last couple of episodes, where we're realizing that the break-off belt magmas have a totally different tectonic story than what was originally assumed, which was just a simple volcanic arc with basalt, andesite, dacite, and rhyolite. But this bimodal thing we're talking about today, with all these break-off belt units, are mantle surging shallower than it should be, decompression melting. And Jeff, prompted a little bit by me, but not much, took some time after thinking about the last episode and wrote this beautiful little essay. I'm going to read it to you here quickly. We'll revisit it maybe at the end of today's episode. Jeff Tepper, bimodal magmatism is generally associated with areas of crustal extension, where the crust is thinner and where large volumes of hot basalt generated by decompression melting are intruding the crust. He's writing this for us, ladies and gentlemen. Thanks to the tensional stress environment, these magmas can ascend to shallower crustal levels, where they trigger crustal melting that produces rhyolite magmas, commonly in large volumes. Because of the very large viscosity contrast, basalt and rhyolite do not readily mix. So intermediate compositions are rare. In addition, because the rhyolite magma is also much less dense, it acts as a density barrier, preventing new batches of basalt or their differentiates from making it to the surface. So here's basalt down below, rhyolite up above, and rhyolite is acting as a density barrier. So this basalt can't get to the surface because this more dense stuff is this stuff is sitting on top of it. This can drive more crustal melting and can also trigger eruptions. If the eruption brings up material from near the felsic-mafic interface, you can expect to find mafic enclaves, ding, 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 in the eruption deposits. Basalts may continue to erupt nearby where they can reach the surface without encountering the rhyolite density filter. Thank you, Jeff Tepper, for your extra effort. I'm sure that all of us will appreciate continuing to read that essay, even in the next couple of letters. The Summit Creek breakoff magma has rhyolite. And in the Mike Eddy conversation, he casually said, well, yeah, one of the first things I did was I went down to Summit Creek and sampled some rhyolite and got a good date on it. And he found rhyolite down by White Pass at 48.086 plus or minus 0.086, towards the top of that Summit Creek unit. There's a lot of basalt, I guess, making up the middle part of it. And then the bottom, Jeff has a date from an ash flow tuff, 53.744, same kind of precision. So my only point here is that even though we're down by White Pass and we have a maximum age for the onset of the Summit Creek eruptions being here, are these dates exactly what they are at the Teanaway? No, but it sure seems like every one of these breakoff belt magmas has arcosic sandstone, has basalt, has rhyolite. And that's our case study today with Teanaway Formation. That's exciting for me. It's maybe not new to these other guys. It's new to me. Also in the Lisa Kant paper with Jeff, they make a quick note that the lavas and sandstones of the Summit Creek unit down by White Pass and the green Ohanapikosh, younger, green in the 30s, they're all tilted. And that westward tilting of those beds happened after the Ohanapikosh. Jeff, I wonder about that. And we're continuing with this uplift narrative. And I don't know if I'll ever come through on coming up with something definitive by the time we get to Z at the end of the alphabet. But ultimately, if I'm dreaming, I want evidence already in this alphabet, like we've already gone through two major uplift events. Like we know we had one folding event below the unconformity to fold the layers in the Swak Formation in the Silver Creek. But I think there's payoff for understanding these uplift histories, if nothing else, to know when the Grello gets to the surface in central Washington. How are we doing? That's the first pass through this stuff. Fast, kind of scattered, regional as well as very precise detail. I don't think it's going to be satisfying for most at this point. But now I've got all the visuals. And we've got more than 800 watching live. So let's go to the visuals and just follow our nose. But I think I can make this work in living color for you now, and we will revisit some of those concepts, but also introduce some new things as well. I'm having a blast. By the way, I just feel like I have to say this. It's the day after Christmas. I don't know how loyal you are to this channel, but you might be surprised to see me doing this the day after Christmas. Like, what is up with you? Do you ever take a break? Don't you have a family? Why wouldn't you take a week or two off for holidays like everybody else? My short answer is we had a break for a month in November due to a family situation. And so we're back to normal in our home, and this is therapeutic for me to work on this geology stuff. That's my answer. We were originally going to take a break when we started this alphabet, but because we had an unexpected break in the schedule, it feels great to be back, and I hope you can feel that in my voice. Here we go. Slides. Take us to the slides. Nice and big. Don't get broken up now with all sorts of tangents. Just keep the momentum going, boy. Okay, as I've mentioned the last couple of episodes, these natural chapters are showing up, and we're still in chapter 3, but we are about to transition to at least 2 letters. Oh, I promised just 2, right? 2 letters on the slab rollback story. And then on whatever the first Saturday in January is, we'll still be in blue, but we will be kicking off the Cascades. Yes, before we kick off the Cascades, we have something different. And this is one of the 3 Jeff Tepper tectonic stories that we are thinking very carefully about in these letters here in December. I don't need to talk about this again. We have a broken plate. We have a broken plate. I don't need to talk about it again, do I? No, I don't. The broken plate allows these break-off belt magmas, including the Teanaway basalt, to show up where they do. Yes, these are all the break-off belt magmas. Yes, many of them, maybe all of them, have a bimodal signature, plus all sorts of, the niobium is off the charts. Look at me. Okay, visuals. So the Roslin Formation is the sedimentary material sitting directly above, on top of the Teanaway basalt. And I want to show you a clip from the older version of Nick on the Rocks. And this guy here, Chris Smart, was the guy that I was making the videos with. So this is the guy that I used to make PBS videos with before Brady Lawrence and Gary Paul. And we chose to do an episode in the Teanaway looking at some really beautiful stacks of sandstone that are eroded into the Roslin Formation. We haven't gotten to the Roslin yet. I don't know how much we're going to do about the Roslin, but I want to start with the Roslin simply to show you how beautiful this area is just north of Ellensburg. Chris Smart, retired now, but he was the main guy that I was collaborating with to make 24 of the Nick on the Rocks episodes before the pandemic. Chris Smart's work, let's go. Let's look at the Teanaway Community Forest for the first time, for many of you. Central Washington, in the shadow of Cascade volcanoes. The majestic Stewart Range presides over a thick forest carpet that stretches from ridge to ridge. Rushing rivers snake their way through the trees, swollen with mountain snowmelt. Has Central Washington always looked like this? Or are there some geologic clues hidden in the trees that tell tales of a much different past? Tropical plant fossils locked into sandstone, like Mammoth Rock here, huge domes of it, tucked into the Teanaway Community Forest, all in the shadow of Mount Stewart. And if you know where to hike, bike, or drive in the backcountry near Roslin, there are absolutely breathtaking towers of sandstone. Look at this guy. This is Exclamation Point Rock, hidden for many, many years in the Teanaway Community Forest. We found it. Others have been finding it. Look at this beautiful shape. These isolated sandstone monoliths and spires are all through this community forest. In some cases, the sandstone monoliths are so large, it looks more like Moab, Utah in the Slick Rock country than it does in the foothills of the Cascades here in the Pacific Northwest. There was a global warming. All right, so thanks to Chris Smart once again. He still lives in Ellensburg. I have lunch with him every other month or so just to keep him updated on what's going on. But he's living a quiet life in retirement, and he did some excellent work with those earlier episodes. Thank you, Chris. So we leave the Roslin and we get to the star of the show today, which is the Teanaway Formation. And just a little heads up, if you look at these dates, this was created by a guy named Jack Powell more than 30 years ago, and I replaced Jack Powell here at CWU. Look at these dates, 52 million years ago for the Squawk, 58 for the Teanaway, 53 for the Roslyn. Those dates have been improved mostly because of Mike Eddy. So here's one way to get into the Teanaway story. This YouTube lecture still exists online. It's one of the first ones I ever made on the Ellensburg blue agates. And I was using information that I had learned at the time from Jack Powell and a few other locals, but I didn't really have much information to go with. And I just went with the story saying, look, the Teanaway basalt is important. I'm paraphrasing from that lecture from more than 10 years ago. Look, the Teanaway basalt is important. And one of the main reasons it's important is if you go to the top of the Teanaway basalt, there are little holes, little gas bubbles in the Teanaway basalt. And that's where the Ellensburg blue agates are formed, in the vesicular top of the Ellensburg, in the vesicular top of the Teanaway basalt. So everybody enjoyed the lecture and lots of nice pats on the back and everything else. And here's a slide from that lecture where I'm showing the blue agates are coming from the top. And then people were like, well, why? Why would the blue agates only form in the top? And why wouldn't there be agates everywhere? I'm like, I don't know. That's just where I found some information. And this is a place called the Hal Holmes Center, where I was giving downtown lectures for a few years. This is a trip to the top of the Teanaway basalt. We're looking south. Here's the Green Canyon Notch, if you happen to know it. And this is West Engstrom, a local celebrity in the little mining town of Liberty. So Wes devoted a few hours to me, and we hiked up to the top of the Teanaway basalt, and he wanted to show me agates being formed in the top of the Teanaway basalt. And sure enough, we got to that vesicular top, and here's some agates, and some of them are bluish. And there were plenty of other agates, big and small, at the top of the Teanaway basalt. In other words, the top of the Teanaway Formation, that were quartz and beautiful for agate hunting. And you take your pick. There's all sorts of basalts from the Teanaway basalt that have these agates filling many of the holes. And over the years, I've had plenty of people visit me in my office, and they always bring in Ellensburg blue agates. And they're like, is this a blue? Is this a blue? And I'm like, yeah, it could be a little bluer. I'm no expert, but quite often they show me basalt from the Teanaway. Okay, we get it. We get it. All right. Just a quick little aside. I don't think I've said this much out loud. Maybe I did once. Are you familiar with these downtown lectures that I give? I do them every year. I really enjoy putting them together. And there will be some brand new downtown lectures this coming April of 2025 based on this work we're doing together right now. The reason that I give these lectures downtown is because this is a conservative area. And by 2010, I had a lot of connections with a lot of ranchers and a lot of people who live in central Washington. And they would come to my field trips, oftentimes in the Teanaway, that were free. We did them on Sundays. And I would organize, with Carl Lilquist, I would organize some guest lectures, and people would come to those. And a bunch of people said, you should do some lectures on all this stuff. I bet you a bunch of people would show up. And I'm like, okay, that's a good idea. Maybe I will. And a bunch of those ranchers said, we'll come, but we won't come if they're on campus. We're not a fan of your campus, your university. But if you come, but if you make those lectures at a neutral site where we don't have to go on campus, we'd be happy to come. We'll bring all our friends. So that's what I did. I found a place downtown in Ellensburg that was this was the old Button Jewelers, and somebody from Seattle bought it and renovated it, and he made it into a rock and roll music venue. He didn't even have chairs. And then I said, hey, how about Wednesday nights I do some geology lectures? He's like, you think anybody will show up? I'm like, I don't know, maybe 100 will show up. He said, well, I got to buy some chairs, but the lighting was so terrible. Anyway, the first couple of years of doing downtown lectures, I did them in that place called Raw Space. And then that got popular enough where I moved to this place called Hell Homes, which is connected to the Ellensburg Public Library. And the library staff was very good. And we had folding chairs we had to set up every time, before and after, I remember. And then most recently, right before the pandemic, starting in 2019, we outgrew the Hell Homes. And so then we went to the Morgan Auditorium in Morgan Middle School, which is still happening. So that Ellensburg Blue Agate lecture is still online and was popular, but I heard from this guy. You never know who's out there watching your stuff. And this guy here, his name is Carl Carlson. And Carl Carlson has spent his whole life running a jewelry shop in Tacoma, dealing with Ellensburg Blue Agates. Here's his card. Shop is still in town, downtown, Carlson Brothers on South 38th Street in Tacoma. Carl Carlson III, third generation of blue agates. And that family purchased mining claims for blue agates. Where? In the Teanaway. And Carl Carlson said, yeah, I saw that lecture you did on the blue agates. Good job. Really enjoyed it. And you're wrong. He said it in a nice way. He said those best blue agates are not coming from the basalt in the Teanaway Formation. They're coming from the rhyolite. And I think I said, you mean there's rhyolite in the Teanaway? I just knew the Teanaway basalt. I hadn't read Israel Russell's detailed stuff. So I got interested in the rhyolite of the Teanaway Formation because of this guy, Carl Carlson, very kindly correcting me, and then not only correcting me, saying, if you're going to do more on the Ellensburg Blue Agates, I'd like you to see if you can learn some new things about the rhyolite of the Teanaway Formation. And for teaching your students, I want you to be able to teach what the blue agates really look like and what their host rock really is. And what is it, Nick? It's rhyolite, not basalt. So Carl Carlson started making trips over to Ellensburg, Kevin Licious, Weininger's ice cream, and started bringing jars full of absolutely gorgeous blue agates from the rhyolite of the Teanaway Formation. This is rhyolite. This is not basalt. And so Carl says, yeah, there are agates in the top of the Teanaway basalt. There are agates that fill those vesicles, but that's not the good stuff. The good stuff are these amazing rhyolite deposits. And I want you to be able to show your students some very beautiful, detailed, not only polished, but unpolished, raw blues that come from our Teanaway rhyolite and the mining claim that they still have in the family. So thank you to Carl Carlson. I hooked up with Carl in the field and asked if I could videotape him in 2021. He said, sure. And so this video is online. And Carl started wowing the crowd at the gift shop there at First Creek and started showing all these amazing samples. And I think once or twice actually said, you maybe saw something on YouTube saying that the blue agates are coming from the basalt. Well, that's this guy over here, this big tall guy. But this is the real story. It's a brecciated zone with all sorts of agate quartz filling the rhyolites of the Teanaway Formation. I hope you're enjoying this so far. Do you know what we're doing? We're doing a deep dive into one bimodal break-off belt magma that has a regional significance of being older than the start of the Cascade Volcanic Arc. But there's so much going on with the Teanaway Formation that I thought I would split out a whole letter to share all this really cool stuff. Not only the geology, but the connections that you can make. If you're a public person, people come out of the woodwork and oftentimes offer information if they can trust you. And for some reason, Carl trusted me. Gave me a bunch of stuff. Look at this. These are blocks of the rhyolite with an Ellensburg blue agate matrix swimming around each of these guys. We have some in the hallways of our building now in the display case. Here's Carl, a few clips from Carl talking to visitors on a special day at the gift shop at First Creek.
It's not blue, it's just a color. But if you ever see this color up in the mountains, you better start digging. You better start stopping and looking, because this is the rhyolite that the Ellensburg blue is formed in. And so when you see that, memorize it. So wherever you're going, look for it, because that will help you out. Because see, on the other side, you just might find something like this. And there we got the druzy on the blue.
Notice his belt buckle there.
At the time you think you got a good place to cut, you get into it, nothing. You can't cut anything out of it. So it's always a big disappointment. So this was still good blue. This one came in and it's blue too. But what we found was that this piece was probably about 50 feet farther up than with this one. Farther up, I mean like say north. And what this does, you see these tiny little cracks in here? We did it one time. We heated up a blue and just ran the temperature up and let it come back down. It loses its color a little bit and you get all these tiny little fractures. So this got heated up, this one not so much because there's just one or two little fractures in it. So there's other stuff going on after the blue came up.
Can I please emphasize here that when you're dealing with money and you're dealing with precious things that everybody wants to find, of course everybody's tight-lipped. Nobody wants to say what they know. They've got their claim, whether it's gold or blue agates or whatever the commodity is, you're going to keep it to yourself. So it wasn't until I started doing public things that I started to make connections with people who saw what I was doing and they offered their information, because there aren't books, there aren't texts, there aren't papers to go read up on some of this stuff. And yet it fits in beautifully with the published Teanaway Formation work that has been put out there for many years. Some of the agates are even green. I have no idea what's going on there, but again, some local collectors would bring in stuff. I'm like, good Lord, that's part of the Teanaway rhyolite as well? They're like, yep. Some of the agates are astounding. They're also in our display cases. Some of these hobby folks just insisted that they give these to us so that we could display them for the public to enjoy. So that's within the Teanaway somewhere. Now the rhyolite, remember what Roland Tabor was saying. He's like, there's confusion. Where is the rhyolite within that? I'm getting to it, I promise. Mike Eddy's going to help us. But let's leave the blue agates for a second. Let's leave the Teanaway just for a second. There's even more information being offered. What do you think the yellow is? Gold. Burst through shale. Sedimentary rock deposited in a vast inland lake.
Red, white, and blue.
I'm all ears. Red, white, and blue.
Red is the basalt intrusive.
Okay.
White is the calcite.
Okay.
And or quartz. And blue is the bluish black shale. Those three, in very specific conditions related to each other, will precipitate out the crystalline wire gold. All the gold in Liberty originated as wire gold.
Oh my God, that's gorgeous. Where's the gold coming from?
The solution is coming from way deep. Gold has an affinity for carbon.
So why do we need the red? Why do we need
That's
that
the heat
basalt?
source.
So the gold is being moved by hot fluids along the
Originally.
margin of that basalt.
Originally, yes. All the heavy gold has settled down to the bedrock that river gravel tumbled over the top
Right.
of.
The panning is more for... Okay, I got to be careful here. I'm not trying to imply that every one of the breakout belt magmas of Jeff Tepper has blue agates and gold associated with them. I'm not saying that. But the Teanaway does have the gold and the blue agates associated. And you're like, what is the detailed relationship? It's still a bit of a mystery, especially the gold. But the gold has been found typically along the margins of those feeder dikes. So there is a rough connection. I am, in the next two letters, going to be emphasizing these rollback magmas, which often do have gold and silver associated with them. But at least in the breakoff belt, I don't think we have all of the blue agates and the gold. Otherwise, I think I would have heard about it by now. Let's keep it going. This is the black shale of the Schwalk, some calcite or quartz, and then wire gold forming nearby. So again, you can't find this stuff in books. You need to meet somebody who's not only willing to talk about it, but another step is to be willing to talk about it on camera. Rob Reppin. Okay, so this Blewett Pass area is rich in these deposits, but also rich in this bimodal volcanism that we're going to get back to now for the rest of today. Now we go back. I'll try to keep this fast. Now we go back more than 100 years to the original publications that you all have at nickzentner.com. Here's some breccia, a brecciated vein in the Schwalk mining district. Whether it's the gold or the blues coming from this, I'm not sure. Is this rhyolite? Is this basalt? I'm not sure. Is this calcite or quartz? I'm not sure. But it's from Israel Russell. And if you were a fan of what we were doing last winter, you remember this guy. This is the guy that died suddenly in May of 1906 at the University of Michigan. This is the guy a decade earlier that was out here doing the first work of the Teanaway. Here's Israel up in Alaska on one of his survey projects. But this is the crew, the type of crew that he was probably with at the Teanaway Formation as well. And here are some of these photos. That same photo I showed you in the document that Pat, the pilot, gave me. Here are those same feeder dikes. We're about to go to the feeder dikes for a little bit. And here's that same photo that I showed you in 1898 from Ingalls Lake, Mount Stewart behind. Here's our boys when they were in middle school and high school. It's a popular destination, Ingalls Lake. Yes, it's Israel that had this high school teacher named Harley Bretz over to his house in March, and then 6 weeks later, Israel dies. But Israel, during that one and only time he visited with Harley, encouraged Harley to move out to Seattle to look at the glacial deposits. And so there is a connection between Bretz of last winter and Israel Russell. Same guy. Following closely in Russell's footsteps is George Otis Smith. And if you're a longtime fan of the channel, in the backyard with Bijou the cat during the pandemic, I was doing episodes on each of these old-time geologists because I was just curious and I didn't have anything else to do. I was trapped at home just like you were. So I was doing a deep dive into the personal history of each of these geologists, but it's George Otis Smith, who went on to become the head of the USGS, that also contributed in a main way in the 1890s and the very early part of the 20th century. So this is from the Mount Stewart Folio, which is a gorgeous work of art. And Smith and Russell are both calling this just basalt. They're ignoring the rhyolite. And the Schwalk is below and the Roslin is above. And the Schwalk is below and the Roslin is above. And they just say Eocene. They have no idea 100 years ago of the age of this stuff. Basaltic eruptions, cracks in the sandstone, serpentinite, slate, and even the granodiorite appear to have been taken advantage of by the extremely fluid basaltic magma, which thus secured a passage upward to the surface. For the most part, the lava spread out in great sheets, while in certain localities the presence of steam in the molten rock appears to have caused explosive eruptions, thick beds of basaltic tuff being intercalated with the lava sheets. Master student Clayton does the same thing. He's helping us try to visualize that this is a wet, poorly drained, swampy area during the Swak time with all those tropical and subtropical plants. And yeah, there's some rivers occasionally coming through from the east, but for the most part, there's a lot of water at the surface and in the subsurface. And so when you start to bring these lavas to the surface, now that's our question for the rest of today. What were the first lavas? Were they the rhyolites or were they the basalts? Can we tell the difference in time? But regardless, those Teanaway lavas, if they're only erupting in less than a 200,000 year span, they're fighting water. They're erupting into an Everglades tropical swamp. And so many of the deposits, the tuffs and other things, are showing that phreatomagmatic relationship. Look at me. Russell, the most marked feature of the region occupied by the Swak sandstone to the south of the Wenatchee Mountains is the manner in which it is traversed by dikes. These are all, or almost all, dark, basic rocks, basaltic in other words, corresponding lithologically with the basalt known as the Columbia River lavas. We know that not to be true anymore. He's talking about the dikes. He's talking about the dikes. Practically, they are countless. In one section near the head of Stafford Creek, just south of Mount Stewart, there's 50 dikes ranging from 15 to 60 feet. Individual dikes can be frequently traced with ease for a mile or two. It's not practical to go further than that because the country is so rough. So these maps are still the best maps that we have of the basalt feeder dikes for the Teanaway Formation. Each of these red lines is a feeder dike, and you can see how incredibly uniform they are in orientation, a northeast trend to them. And this Mount Stewart folio, published in 1904, has not only the maps with each red line being a basaltic feeder dike, which is just a crack with basalt lava coming up through, but also cross-sections. And in the day, they would lay the cross-section on top of the map to show the relationship in underground view. Gorgeous. Here's Liberty. Here's Rob Reppin's gold mine. Here's Blewett Pass. And here is there's a bit of folding of the Teanaway basalt. That's why it looks kind of funky on the map. Let's go backwards and just get a regional portrayal of the Silver Pass volcanics, which are down during the Swak Swamp, and then the Teanaway nearby. I showed you this a few letters ago. Let me show it to you again real quick. Excellent. On the Teanaway basalt. We're going to talk a fair bit about the Teanaway basalts, or the Teanaway Formation, this upcoming winter. And this is the visual I'd like you to have. Yeah, this is the same Teanaway that's exposed at Liberty, Washington by Rob Reppin's gold mine. And yes, the Teanaway feeder dikes are all through the Blewett Pass area, but those feeder dikes, which are down here in the trees here locally, I mean, there's a bunch of cracks that formed 49.3 million years ago, and those cracks, those feeder dikes, fed the Teanaway thick basalts that capped a swamp back during that time. I mean, we're back at the Eocene. All right, so here's one of those dikes. It's my favorite because it's on the old Blewett Road. This is just one of the 400 basaltic feeder dikes that used to feed a capping thick Teanaway basalt. We're not looking at the rhyolite yet. No, we're just looking at the basalt. Here's a video clip that I found this morning. 1, 2, 3, 4, 5, 6, 7 people, 1 dog, 1 outcrop.
because like some of the sandstone on the outside like, looks kind of like basalt, you know?
I want to go on a really dangerous adventure outside.
No, that's still basalt. This is still basalt. Right
I'll
here.
take you. Let's go.
Or look,
I want to physically encounter basalt. Don't put them off on
So we're just going to kind of let these guys take a look at this excellent outcrop, have them think about a few things, and then we'll maybe have a little group discussion. But it's an accessible favorite spot of mine, and it's accessible to you as well. It's the first major hairpin that you go around as you head north on the old Blewett Road. All right, let's try something real quick. A few of you have seen me do this before, but let's try it anyway. Why are those dikes so well behaved? Why do they all agree so carefully? And what's it got to do with tectonically? Let's try. So you saw that map of Smith's from 1904, and they're showing up pretty much just in central Washington. Now, why do they have this, let's make it up, north 50 degrees east trend? Well, they're cracks, and the cracks have basaltic lava coming out of them. So if this is north and this is south, if each of these cracks has a northeast trend to them, and each of these cracks literally opens up and basaltic lava floods to the surface and buries the whole scene, and that's what we're talking about with the Teanaway basalt. That means that each of these cracks is extensional. And so the question is, why are the cracks forming and why are they opening up in a northwest, southeast sense? Are you with me? We're talking about these almost impossibly perfect cracks. They're perfect because they're all oriented exactly the same way. There's 400 of these things. They're only from the Teanaway time, and it's only the basalts that are coming up through those cracks. But it's really just a question of why did the cracks decide to form roughly 49 million years ago? Well, what do you know was happening on the most grand stage in the neighborhood of 49 million years ago, more precise, about 51 million years ago? The accretion of Silesia. This is Ray Wells and others coming up with this connection. And so the idea is, if we have Silesia arriving, these are supposed to be big arrows. That means we have a tectonic collision going to the southwest, that's North America, collision either going to the northeast or just staying put, that's Silesia. But regardless, we have a collision like this, a northeast-southwest collision. Why are those cracks forming if it's a collision? I thought you said, you're talking to me now, I thought you said those cracks formed and opened up and had a bunch of basalt come out of them. I did. Well, why would you have cracks open up if there's a major collision between two major things? And the answer is, if you take a coin purse and you squeeze the coin purse from the northeast and the southwest, you're going to open the coin purse in the opposite two directions. You're going to have extension northwest and southeast at the same time that you're squeezing northeast and southwest. Does that work for you? Let's move on. Sorry. So there they are. All of these gorgeous feeder dikes oriented in this way because of a major collision of an oceanic plateau that nobody knew about back then, nobody knew about in 1973, nobody knew about in 1984. Look what else has a north 50 east degree trend. The rhyolitic breccias, according to local expert Carl Carlson.
The rhyolite already had formed, and hot solutions or whatever came up and broke the rock apart. It's called brecciation. And then right behind it comes the Ellensburg fluid, and it holds the pieces apart, and then it solidifies. That's how you get a breccia. And
That's
so
what it looks like.
an Ellensburg blue breccia is not easy to find, not easy to come by. You don't find it just anywhere. But that's one of the clues of what's happening in this one area. Basically we had three different areas we dug Ellensburg blue out of. One was a hot springs environment, one was a hydrothermal vent, and one was a fracture zone.
A what
And
zone?
fracture, where it just
okay.
broken up. And so I thought, man, how come this coming in all these in different environments? Well, you learn some things. What happened was that the farthest one up where all the fractures at, guess what? They're all near vertical, and they all go north 50 degrees east. The veins do. Go back down to the hydrothermal vent, guess what? The vein that went through there is north 50 degrees east. Guess what? Those three deposits line up north 50 degrees east. And so it's bigger than the individual environments. It's a major fault that it's following, and the major fault got down deep enough to get that rhyolite to come up as veins, because you also have you've been there to that major rhyolite, but there's nothing around that.
Right.
That's just a mass.
Yeah.
So this stuff to me is the last hurrah of material coming up, and always when you get the last hurrah on an igneous type body down in there, you got these solutions of goodies. And sometimes in some areas you'll find rubies and gold and silver and everything of the stuff that kind of came up. So to me that could be, but I've stepped out on a limb because I don't have any proof. That's just me talking. So be good to me.
I find that very interesting, that the veins that Carl has with the precious rhyolite and the blue agates also have the same trend as those basaltic feeder dikes, which are not valuable at all. It's just a bunch of worthless basalt sitting inside of those cracks. But you're like, hang on, I'm losing it now. Was the rhyolite before the basalt or after the basalt? And that's where we're headed before we finish today. We need Mike Eddy's precision to try to shed some light on that. Yep. Red top is where we're going. Clayton's master's thesis has all sorts of detail. Let me just grab a little bit. He's talking about the moist climate. We've already done that. Clayton's thesis also refers to the mapping of George Otis Smith. And now let's look carefully. This is the Teanaway basalt and map pattern. But wait a minute, there's rhyolite that doesn't really follow the map pattern. There's a blob here, there's a blob here, there's a blob here. What is going on? Is this rhyolite part of the Teanaway Formation or is it not? Here's Clayton in 1973. Several isolated exposures of rhyolitic rocks were mapped long ago. The rhyolites were considered to be Pliocene lavas by Smith. And post-Roslin volcanics and intrusions by Foster in 1960. Foster also suggested the rhyolites represented different ages and that some appeared to be interbedded with the Teanaway basalt. Both authors noted that it was difficult to determine the relation of the rhyolites to the surrounding rocks. Please put yourself in my position in the last 6 or 7 years. I now know there's a bunch of rhyolite in the Teanaway thanks to Carl Carlson, but I don't know where it's located. I don't know the outcrops, and I want to be able to teach about it, but I don't know the age relation between the rhyolite in the Teanaway and the basalt in the Teanaway. I didn't make the total connection until the last couple of days, if you really must know. So let's get to it. More from Clayton. Sorry. The Teanaway basalt consists of basaltic lava, tephra, shield. Rhyolitic volcanism was most active during the latest stages of the Teanaway volcanism, produced lava, ash flows, and airfall tuffs. Extrusive domes were probably formed. This guy's all over the place. I need definite answers now. I'm starting to get pissed. Tell me about the rhyolite. The greatest volumes of rhyolitic rocks are exposed in 2 thick piles near the North Fork of the Teanaway. These exposures are both close to the top of the Teanaway. Okay. Many thinner rhyolite flows and tuffs are found scattered throughout the formation. The most accessible of the smaller deposits are 100-foot thick rhyolitic flows or tuff 1/2 mile to the southwest of Red Top Mountain, Lookout, and a thin amygdaloidal tuff bed exposed for over a mile along the Teanaway Ridge to the north of Red Top. Now, it's Monday of this week. Mike is not feeling great. It's right before Christmas, and yet he says, sure, I'd be happy to talk to you for half an hour. So this is Mike Eddy from his home in Indiana, and I loved how precise, no surprise, and how on the mark his answers were from more than a decade ago with his field work, totally helping us with this rhyolite question. Go ahead, Mike. The Teanaway Formation is bimodal, and it shows up and kind of interrupts this sedimentary sequence you're talking about, the Swak Formation below and the Roslin Formation above. Did you contribute, I know the answer to this, did you contribute to the geochronology of the start of those Teanaway lavas, the end of those Teanaway lavas? Let's start there.
Yeah, so the Swak Formation that's underlying all this has a bunch of well-documented volcanic interbeds in it. So we knew about those, and we were able to date those pretty close to the top of the formation. And then we knew there was an unconformity, an angular unconformity between that and the Teanaway Formation. And basically, that means that the Swak Formation was deposited in these broad, flat layers and then was folded and partially eroded before the Teanaway volcanics erupted. And so we were thinking about this ridge subduction process, and we thought, well, here's an unconformity. We got to know when this happened. The Teanaway Formation previously had a few rhyolites described. I think a master's thesis by Clayton described some.
Yeah.
But to the best of my knowledge, the only existing, you're all set, Nick.
I'm deep in. I've been having a blast, but also have been confused. I think that's where you're going right now. Clayton's like, yeah, I think the rhyolites are at the top or they're in the middle, and then you're saying they're at the base. So like, where are these rhyolites within the Teanaway Formation? Top, middle, bottom, all?
It's a great question. So I thought, well, we need a date for this. The only existing dates were potassium argon dates from quite a long time ago.
Yeah.
And so I found somewhere, and now I can't remember. I thought it was Clayton, but I can't remember. There was a description on Red Top Mountain of a rhyolite at the base. And so I parked over there, walked up to the fire lookout, and walked along the ridge. And if you go do that, you're going to see that there's like very little outcrop.
Right.
And then I ran into somebody who was up there, some local person who was looking for minerals. So I guess there's like agate that forms.
It's a war zone up there. They're looking for agates like crazy, blue agates and gray agates and everything. So yeah, so you ran into somebody who was just hunting for agates, and
I didn't realize it, but I guess it was forming in like cavities in the rhyolite. So there was like this pumiceous rhyolite, and that's where people are mining out the agate. So then I started to notice that the ridge was like pocked with holes where people had dug in, and was able to dig in with my pick and find some of the rock and get a sample out. And that's really our only date for the Teanaway Formation is the rhyolite from Red Top, which is at the base. I visited other places where I sampled things. I don't remember if I even processed them or not, but that's the only one that worked.
Okay, a couple things there. How did you know you were at the base of the Teanaway up at Red Top?
Just from the map pattern,
Yeah.
from the existing geologic maps.
Okay, so we're going to go long. I still got a bunch. I love this stuff. It's local. It's new information. There's a changing tectonic story. I hope you're still with me. But we're going to go another 15 easily before we get to live question and answers. Just letting you know. Okay, thanks. So Mike was talking about being at Red Top, and this is the SWAC, remember, that's full of the feeder dikes. And so this is older stuff, then the Teanaway, then here's the Roslyn that's younger. So everything's kind of dipping to the west. So we are at the base of the Teanaway basalt. So you're like, oh, cool. All right, so we got that cool date, that very precise date from Michael Eddy, 49.303 plus or minus 0.03 or whatever. That's it. The rhyolite's at the base. And yet there's more rhyolite up there that Mike published on, and he did get dates. That's the last section of this. Look at these things don't follow the map pattern. Are these way younger? I was out with Andrew Sadowski, not knowing the age of those rhyolites. Here's a little bit from Andrew. That I was hard on the hunt in spring of 2021.
An argument. This is again my first time being here too. So like, it might not be hydrothermally altered. Instead, maybe it's just pretty thoroughly weathered, and what we're seeing is kind of the weathered surfaces here and there. Things like thin sections and geochemistry might help us elucidate whether or not there is like a secondary alteration process acting upon here.
So that's Andrew Sadowski, who has an office just down the hall. He works for the Washington Geological Survey. He was relatively new to the area at the time. He had the key to get through the gate at First Creek, so we drove up with his big fancy rig, and I just said, I want to find some of this rhyolite. I don't know the age of it. I didn't know where Mike got his 49.3 million year old date. You'd think I would, but I didn't until earlier this week, the Red Top story. I don't know the age of this stuff here, but there's beautiful rhyolite exposures in other places. So we're back to the same question. Is the rhyolite only at the base of the Teanaway Formation, or is it interbedded with or even sitting on top of the Teanaway basalt? Let's keep going with Andrew. Don't advance. Excited right over there because it was such a beautiful pink, and to me that looked like super fresh and pure, and this is like was pink but has been
like here's like a little bit of that pinkness that you keyed in on, which I didn't mean to kind of poo-poo it, but like I think there are a lot of things happening on that.
Sure.
Just like there's a lot of things happening on the surfaces.
Well, yeah. So right below we're back to that good-looking pink, at least to my eye, and maybe the camera will pick it up as well.
Yeah, it's a beautiful piece.
So you're
Hollywood.
Oh, see now, well, there's your blotching.
Yeah.
But there's much more pink than we had.
Yeah, I think some of that's hematite.
You do.
I do. I mean, like, it's hard when it's so close and when it's in rhyolite. Can't tell it.
All right, back to Clayton. The rhyolitic rocks are characteristically cream-colored on fresh surfaces, but light green, purple, and gray varieties are also found. They weather to a yellow-brown, often with arcuate bands defined by iron oxide concentrations. The silicic rocks are apparently resistant to erosion, judging from the steep, sided knolls they form. Nevertheless, outcrops are rare on undisturbed ground. That doesn't sound like the stuff we were just looking at with Andrew. I'm not sure it sounds like the stuff up at Red Top either. What is this stuff he's describing right now? Is it possible there's some rhyolite in the Teanaway Valley that's not technically part of the Teanaway Formation? The answer is yes. There's an overprint of far younger rhyolite on top of a much older Teanaway Eocene story. Brand new to me this week. Merry Christmas, everybody. Rhyolitic volcanism contributed to the deposits of the Teanaway. Intrusive rhyolitic rocks are probably present also. The feeders for the rhyolites are apparently not associated with the Teanaway dike swarm. So now my mind is swimming this week as I'm getting ready for today with you. If there's Teanaway rhyolite that's not Teanaway Formation rhyolite, but it's like in the 20s, like we're talking about Teanaway rhyolites that are in the 40s, 49.3, that's the Teanaway Formation. But we're about to learn that Mike has found some Teanaway rhyolite that's in the 20s. How do you explain rhyolites that are half as old? That's what I'm currently jazzed about right now. Mike, besides that rhyolite at the base of the Teanaway Formation, can you say anything else about the rhyolites that you remember stratigraphically within that Teanaway Formation?
Well, we never were able to date the top, which is a challenge. Our best constraints come from taking sandstones from the overlying Roslyn Formation.
Yeah.
And basically dating all the detrital minerals, so like little zircons that would have been in the river sand, and then finding the youngest ones. And then we know that the sandstone had to be younger than the youngest ones, which is a very unsatisfying date.
Yeah.
There were a couple rhyolites that were mapped, I believe, by Clayton towards the top of the Teanaway, maybe even interbedded into Lower Roslyn. And I beat back in the bushes to find those. I think you went to one of these places.
Yeah.
I think I've seen a video.
Right.
And sampled it and I dated it, and it was like Miocene. So it was much
Yes.
younger. It's like modern Cascades. And I have not been back to those places because I thought, well, this is a little bit outside of my what I'm studying right now. But those are very interesting. I mean, they must be intrusions. And they are much, much younger than all this activity and a little further.
Are you still with me? His dates for some of the rhyolite in the Teanaway River Valley are in the neighborhood of 25 million years old. Do you have a guess why there would... We have the Cascade Volcanic Arc 25 million years ago. Warning, there's a potential connection to Mike's Spirit Lake Pluton project. Yeah, this is the guy that's doing the Spirit Lake Pluton project. If you haven't made that connection before, the Spirit Lake Pluton is in the 20s. Let's keep going. This is an unexpected turn for me and possibly for you if you're deep into this episode. This is the video Mike was talking about that I must have sent to him. I said, hey man, I trekked down one of your weird rhyolite deposits. Apparently. So, being out with Mike Eddy, I know that he's very, very careful to make sure that he's sampling bedrock and that he's not sampling just a bunch of talus from some, quaternary deposit or something like that. So I'm confident that Mike Eddy would come here and say, I've got to get a sample of this rhyolite. I want to figure out, maybe Mike was I'll double check with Mike, but I wonder if Mike was like, I wonder if this, how does this fit into the Teanaway Formation story? I'm guessing, and then he gets the results back and he's like 26 or 25.6, what? So my point is, I'm sure that Mike scrambled up this place like we're going to right here. Now, can Daddy do it without falling? It's steeper. Oh boy. Oh God. Okay, I'm sitting in the I'm sitting in the talus slope. It's too steep for me to. So we're pretty bleached out. Let's try something else. Pretty fine grained. I think my goal here is to see if we can get a decent fresh surface and also see if there's any phenocrysts or any minerals to observe. Carl Carlson seems to think the rhyolite is way younger than the basalt. Carl Carlson seems to think that the rhyolite is way younger than the basalt, like 20 million years younger than the basalt. Major part of the story even during the basalt and after the basalt?
Well, the basalt, to me, the basalt was there. Has nothing to do with the blue.
Yeah.
The hydrothermal vent came up through the basalt. Has nothing to do with the blue.
Okay.
But it takes the basalt and makes it go green because the hydrothermal vent type material will take mafic minerals and change them to chlorite, which goes green on you. And in the hydrothermal vent, there was cerussite. But on the edge of that hydrothermal vent, there was an Ellensburg blue vein that came by. There was also other little places in there that you could find once in a while some blue and so forth. So that came by, but as far as heating and so forth.
That one. And yes, it was in the 20s. And you've got a couple of those rhyolites from the Teanaway that are half as young as they should be or half as old as they should be. I mean, all I've done so far is like mentally wander to the Snoqualmie batholith and say that thing was active in the 20s. I mean, similar to your Spirit Lake Pluton active in the 20s. So like, I don't know, would we have some silicic plugs shooting off of the Snoqualmie bath? Am I saying that right? Is it? Yeah, it's the Snoqualmie batholith. I mean, it's tantalizing to come up with a tectonic explanation or even to correlate those Miocene rhyolites in the Teanaway Valley with something nearby. And I don't know, maybe if you get cooking with the Spirit Lake Pluton project and there's some rhyolite plugs off to the east, that would be an interesting corollary to what's going on at Snoqualmie Pass, and then this like Mount Daniels or something. I don't know what I'm talking about right now, but I feels like that would
Mount
go ahead.
Mount Daniels is pretty close by, and it was definitely erupting around this time. So when we were planning this proposal for Spirit Lake, we were torn between doing the Mount Daniels area and Spirit Lake. And ultimately, I decided that it would be easier to pitch if we went with Spirit Lake. So we looked, Isla and I and Bobsy looked pretty hard at Mount Daniels, which looks like just a beautiful place to go do some geologic research. But
there's less trees there than down in Mount Spirit Lake, as you found out last summer.
Yes, there are definitely less trees, but a big climb to get there.
That's true. Let's not. All right. Thank you for hanging in there this long. This is an extra long episode. I think we're about done. I wanted to get to this point. And if you're losing it like Mr. Tony's losing it, we're mostly talking about the break-off belt magmas, which are between 51 and 48 million years ago. And there's a nice, tidy picture with those magmas coming up in central Washington because of a broken Farallon plate down below. And why is the Farallon plate broken? It's because we just added Siletzia and we had a hard time dealing with that massive plateau choking the trench. But the twist here in the last 10 minutes of this episode, unexpected to most of you, unexpected to me until this week, is that we have magmas from the 20s potentially tied to the Cascade Volcanic Arc in the 20s. And when we finally get to the 20s, I don't have to be worried. I don't have to worry that everything's going to be boring once we get out of blue and into green and then red. The red is going to be a fertile time for us, not only with the Spirit Lake Pluton to the south, but the Snoqualmie Pluton, the Snoqualmie batholith, and potential offshoots of rhyolite showing up north of Ellensburg and potentially having the blue agates. Ultimately, that's what I'm saying. I'm wondering if the blue agates are tied to the 20s and not the 40s. I don't know the answer, but this is a whole new turn based on these new dates coming from Mike Eddy. If you haven't gotten it yet, up until Mike Eddy shows up on his white horse, everybody assumed that every rhyolite in the Teanaway area was part of the Teanaway Formation. But if we look at the map, we can now see, look at this. These can be way younger. They don't agree with this map pattern. They're not folded, I don't think. They're rhyolite intrusions that for some reason are coming off of the Cascade Volcanic Arc, potentially, at least timing-wise. These are in the neighborhood of 25 million years old compared to this stuff, which is 49.3. That's the point. I think I'm going to skip whatever I have left, except that here's Mike with his paper showing a bunch of rhyolites in the Teanaway, in the Natchez, in the Tainum, in the Silver Pass, all the breakout belt magmas. Mike Eddy saying it's not all Teanaway. Mike Eddy saying that there's some rhyolites way up and out of the frame from the 20s. We're going to skip this. And it's not all this. Potentially, we have offshoots of rhyolite from this at 25 million years ago. Okay. I had a few other things planned. I don't want to do it. It's 1:30. It's time for some live Q&A between moi, that's French, and you. We have still 900 viewers live, and I've noticed people are getting behind on the alphabet, but we still get up to about 10,000 viewers for each of these episodes. It's nice to see that. People are sticking with it. They're watching these in replay days, maybe weeks, maybe months after the fact. But, we haven't had a precipitous drop-off in people participating, so I just want to keep rolling. And even if we did, I'd probably still keep rolling with this alphabet. But it's nice to see many of you staying connected with what we're doing here with this series. This was a deep dive into a local area, but I hope that you can see many different local geology stories that plug into two major themes: the breakoff belt and the volcanic arc in the 20s, with plenty of major mystery remaining. I'm stalling for you. I'm waiting for some uppercase. We don't have any? Is there an association between the formation of blue agates and their depth of emplacement, a la garnet formation? I know the chemistry is not identical, but some kind of pressures, but think some pressure would be required. I've done what I can, thank you for the question, with adding some new questions about the blue agates. But the depth of emplacement is tough for me. I don't know enough mineralogy. I don't know of any garnets associated with the blue agates. Cindy, can dikes be rhyolites? Well, the trend of those rhyolitic veins, or those fracture zones that have rhyolite and blue agate, also had the north 50 degrees east trend. So I guess that's a vote for the blue agates to be back with the Teanaway Formation time, now that I think about it, Cindy. Thank you. Is there someone we can go looking for blue agates in Washington? Yes, there's a place called First Creek Gift Shop, and they can give you some local directions. Jackie, rhyolite also pink and red per Google. Pink associated with blue agates? That was one of the major surprises from this episode for me, Jackie. That I thought the blue agates were only tied to the brown and black basalt, but thanks to Carl Carlson and others backing up his story, that most of the blue agates are tied to the pink rhyolites and not the brown basalts. Jim, with regards to the break-off belt, why would the break just be at the spreading ridge proper, it likely being the thinnest place and likely the weakest? Thank you for bringing up the spreading ridge, Jim. That's the next episode. I've been trying to hold some of you off who are deeply in love with spreading ridges, deeply in love with the Yellowstone mantle plume. You can't wait to get those elements into this tectonic story. We will go there on Saturday. Chris, do the magmas of the 20s, the upper rhyolites, the start of the modern Cascades? Not quite, Chris. Thank you. The Cascade volcanic arc starts 46 million years ago. So we're 20 million years into the Cascade volcanic arc story before we start our upper Teanaway rhyolites. I like that phrase, by the way. I'm going to steal it. The upper rhyolites. Sky Cooley. Are the Teanaway dikes rotated clockwise? Thank you, Sky. Not much, if they are. The clockwise rotation of those same dikes impacted. Try again. There are also dikes that formed in Oregon, in the western Oregon Coast Range, where Silesia slammed in as well. Those dikes have been rotated almost 90 degrees away from their original position. I guess about 50 degrees now that I think about it. 1 degree of rotation every million years. And Ray Wells was careful to show that. And I'll do a little bit of that dike rotation next time. But when we get up into north central Washington, we're not swinging that clockwise door nearly as much. And I would bring that up occasionally to Bob Miller, who published a brand new Dykes paper, Eocene Dykes paper. I said, what about the rotation up here, Bob? He's like, I've looked carefully at that. We're not doing that much rotation here in central Washington. Thank you. Jim, are the rhyolites intrusive or extrusive lava flows or both? Great question. I think that, here's my guess. The youngest rhyolites are intrusions. They're domes that are just kerplop. They're just pink domes that are showing up where they feel like it, and those must be intrusions to the point of then doming at the surface. But I think there are, well, hell, this is, I showed this a couple letters ago. This is a glassy vitrophere from the base of what everyone agrees is a pyroclastic flow in the rhyolites of the Teanaway Formation, perhaps that one at the base at Red Top that Mike dated at 49.3. In that case, it's not an intrusion at all. It's a, dare I say it, a supervolcanic explosion. I mean, part of me, I'm going way off script now, part of me wants the Teanaway event to start with a bang, with a caldera and a series of hellacious rhyolitic ash flow tuffs and pumice and ash falling out of the sky. And part of me wants that to happen because that's the story of Goat Rocks. You remember Hannah Shamloo? Goat Rocks 3.2 million years ago starts with a bang. Starts with pure rhyolite, with a true caldera. Is there truly a caldera in the Teanaway 49.3? I don't think we can rule it out. But of course, if there was a caldera there, it got totally buried by the Teanaway basalts. But it seems like that confusion about whether the Teanaway rhyolites are at the base only, or at the top only, or interbedded only, I think the answer is all of the above, in part because Mike has some dates from 49.3 and also from 25.6 or whatever those other ones were. I'm down to live. Thank you for the questions. Joe Slick Live. The subduction started with the creation of the Cascades. Do we know what's causing the intrusions in the 20s? No, but I guess I will keep an eye on, once we start the volcanic arc, how far east and west are we getting volcanic activity or even plutonic activity? Like as the crow flies, what is the distance in the 20s between these rhyolite plugs in the Teanaway and the crest of the Cascades? It's probably not that much. Mount Daniel's erupting. Yeah. Sharon, could there be related rhyolites along the south shore of Lake Chelan? I'm not sure. There are Eocene dikes. There's basaltic dikes all through Lake Chelan country. It's like the mafic enclaves. Once you look for the black basaltic dikes, you see them everywhere in the North Cascades. Regine, do you think the rhyolite opened the way for the basalt? Possible. Thank you. Do I know what causes round quartz river Sorry, not on topic. Bob, if the valuable elements in the Teanaway may be younger, how much does this relate to other similar intrusions like the chalice or completely different? Thank you, Bob. That's one thing we're doing in the next couple of letters is talking about Eocene magmas, the chalice magmas, stretching back into Idaho and even Montana. And most of those chalice magmas have gold and silver associated with them. So that continues to be a major vote here to have the gold and silver and blue agates, I guess, all tied to the Eocene time, tied to the blue time and not the red time. That's another way to say it. If you know our colors, we've been looking at the Teanaway lavas today, but we're realizing that a bunch of the Teanaway lavas are blue, but some of them are red. And none of them are green, apparently. So it's bimodal here. I don't think anybody's saying it's bimodal here. I think they're just saying the rhyolite. Or only one guy's saying it. But even if you go back to the 1890s, Russell and Smith are talking about these younger rhyolites. Like they had it mapped long before plate tectonics. How about three more and we're done? David, could I say the 49 million-year-old rhyolite is bimodal, but the 25 million-year-old rhyolite is BADR? Thank you. Yeah, you can actually BADR into it. Thank you. That's the other half of Jeff's essay. Chris, when we get into the next episode or some point down the road, can we cover briefly the Newberry trend as it seems related to the Yellowstone trend and how those relate to the Cascades? Maybe. We might get too deep down there. Maybe so. Kyle, Crooked River caldera timing is roughly correlative with the rhyolites of the Teanaway. Oh. Crooked River caldera is, I think, 29.5. You're right. It's in the 20s, but almost the 30s. Backcountry Gary Paul, do I think the young rhyolites might be related to the Wenatchee domes? Thank you, Gary. Well, the Wenatchee domes are 44. So no, I don't. So that's an interesting take. I think in the next two shows, I'll be trying to visit as many of Jeff Tepper's magmas between 52 and 44 as I can find, including the Wenatchee domes. So the dome, that's an interesting thought, Gary. The dome structures maybe work in Wenatchee, but the domes are way younger in the Teanaway, apparently. Like, I haven't even been to those domes. I guess I have been to one. That quarry's in a dome, but the other one is near 29 Pines, if you know that campground. That's the other place that Mike sampled. That's how we'll finish. If you really want to visit these two young domes in the Teanaway, Mike has detailed GPS. Let me find that. Let me find that before we quit. Hang on, Patrick. Can't find it in the papers. Let me go online. It's 2015 paper here. So this is the first major paper by Mike as a grad student. And here's his, yeah, he even has it. So here's Mike Eddy, 2015. He's like, yeah, I got these two rhyolites. One's 25.6 million, one's 24.2 million. He's labeled them Cascade Arc Magmatism. I didn't even notice that till right now. But my point is he's got detailed latitude and longitude. And that's how I found the quarry. I forget which is which. I guess this is the quarry where I showed the video. And then this other one is if you type that into Google Earth, it's right close to 29 Pines, up Jungle Creek, I think it's called. Fun. It's like half detective work, half history. Same thing, I guess, kind of. Not really. Like, this is not that long ago, and we're just following the clues with this young guy, Mike Eddy. I didn't see the connection to Spirit Lake Pluton at all. That's what gets me excited right now. We have a local story here that might actually help us better understand some of the Spirit Lake Pluton stuff once we get to the 20s. A toast to you. Here's to you for visiting in live or in replay to this episode. Thank you for being here. Here's to hopefully a special week that you've enjoyed with many special people in your life. Here's to the hope that it doesn't have to be just this week, that you can find times to visit with special family members and friends all times of the year, not just now. Thanks to the person who sent this out of the blue, no name, kind of a clever gift. Thank you to Oscar in San Diego who sent me a space heater for the office during this time when they have the heat off. Thank you for that, Oscar. And I think we'll finish today with a couple final looks at the blue agate samples up close. And even this little gift that Rob Reppin gave me, which is a little piece of wire gold. So I'll finish this one with detailed stuff on the document camera, but otherwise I say thank you. I love you. And we'll see you all Saturday morning at 8 a.m. Pacific time for the first of our 2 rollback magma episodes. That's Saturday, December 28th at 8 a.m. Pacific time. Thanks, everybody. We'll see you next time. Have you shut out the window? A shot with the shelf. And Docky. Better with the light off. Like, how old is this rhyolite? Is it 49.3? Is it 26.5? Be nice to know. I think that's a new one.